All right, here is your other lesson. Let's try and get through as much as we can here, please. This teaching point, I'll be able to identify and explain the types, causes, and scientific principles of mass movements and understand their impact on landscapes and human activities. So, the warm up for this lesson: how can mass movements like landslides, mud flows, or rock falls impact? We have the environment, soil, water, plants, animals, people, homes, roads, safety, and infrastructure, bridges, highways, and utilities. All right, so mass wasting events is a type of disaster, natural disasters that can happen. Sometimes it can affect a lot of people, especially if it's suburbia or urban areas. Rural areas, not too much in terms of affecting areas. Right, could affect livestock. All right, so mass movements, we can have falls, we can have flows, and we can have slides. So falling, there's really, I think, only one type of fall called rock falls, and that's a straight plummet down to the ground with very little to no contact with the surface to either flow on or slide on. Rock falls is probably dealing a lot with the freeze and thaw aspect of rocks, breaking apart rocks, especially at cliff faces, and falling down that great distance. A great example could be at the base of the Grand Canyon. Many rock talus formations that are there. um, all right, so the environment, soil. So soil can be affected with landslides because you can have soil that can slide on land. You can have soil that can act as flows for mud flows. All right, no soil for rock falls. Right, those are rock masses. Uh, Water. We need to have some saturated soil or saturated sediments. Probably make it easier to flow downhill. Plants. Plants can be a pretty good helper. Well, no, not so much plants. Trees, vegetation. Trees are much better, right? Trees have more massive root growth. However, even smaller vegetation like grasses, you have like that webbing of root systems, right? That can really hold the soil together quite well. Animals, livestock, we went over that a while back, right? Livestock can eat away at the grass, and while eating away at the grass, could also increase erosion and can increase the chances of mud flows or landslides. People, right? We tend to devastate some areas of land All right, so when we build houses or homes, we may have to take down trees, deforest, taking root systems away, making the soil more vulnerable for movement and flow. um, roads. Roads can be an easier way for runoff to happen. And in order for landslides or mud flows to happen, you definitely need some impervious or impermeable surface in which water can flow. Infrastructure, bridges. Well, bridges is over water. I'm not going to get much into that. Highways is something else, though. Um, if you ever drive with your parents upstate New York, you definitely see rock masses, big, massive rock masses on either side of you. All right, what we do is we cut through the road and cut through the rock in order to uh, make these major thoroughfares, these interstates. And when you cut through there, you're increasing the slopes of land in which you can have a lot more rock falls and sliding and possibly flows. All right, definition mass movement. The downhill movement of soil, rock, and debris due to the force of gravity without the aid of a transporting medium. All right, without the aid of uh, water, air, moving ice. Right, so gravity plays a major role here. Also called mass wasting, or just simply put, gravity. Gravity could also mean the same thing. Here are some variations of different types of mass movements. All right, we have landslides. It's getting a little more intricate in terms of what types they are. We have rock slides, in which rock masses can slide along the surface, and eventually it will flow fast at the top, but once it gets to a flat lying area, it will slow down and deposit. So just like glaciers, these sediments are usually going to be highly unsorted, angular in shape, right? Not too much weathering going on. Rock falls, very steep cliff face. Oops, sorry. We have rock masses. Right, here's a side view of just big portions just toppling over, not like boulder-sized pieces. All right, down below we got some flows. We have some debris flows. We have debris avalanches. Also, snow avalanches can be the same way in terms of the flow. We have earth flows, which is not a fast one. We have creep, soil creep, which is extremely slow. All right, and then there's lateral spread, which I've not heard of until now. All right, types of mass wasting. We have falls, slides, and flows. Under slides, example, rock fall. Speed, very fast. These are really fast because there's no other means of slowing down the rock mass other than the air being the only resistance. So that's extremely fast. Slides. All right, examples. We have rock slide and slumping. This can be moderate to fast. Flows all around, big variation here. We can have fast and very slow. Your very slows are going to be your creeps. Creep is the slowest altogether. All right. Fast ones can be your debris flows, and moderate ones can be your mud flows and earth flows. Lahars are very special too. Lahars, if you ever seen any specials about Mount St. Helens, you may have heard the word lahar before. And lahars are basically mud flows that flow downhill along with molten hot rock lava. So very hot mud flows, basically. All right, next, triggering factors. We have gravity is the main driver for mass movements, bringing it downhill or down slope. Number two, that's important to water. All right, so saturation of soils will reduce cohesion, right? And cohesion is the stickiness between sediments, between loose particles. All right, so if you reduce cohesion, you're reducing the stickiness, and therefore it's able to begin to flow. All right, slope angles and composition of the earth material. So very high angles, likelihood of mass movements. Low angles or relatively flat, you have really little to no worries about mass movements unless you're living in a valley in which you're surrounded by some steep slopes. And your composition of the earth material is, are we dealing with solid rock, like bedrock? Are we dealing with loose sediments, soils? Are they compacted soils? Are they loose soils? So there's a lot of factors involved with the composition of what the material is, especially downslope, because that can be your foundation. And if your foundation breaks down, the whole mass can begin to slide or flow. All right, next, vegetation loss. All right, vegetation loss, big thing because root systems can help retain that soil. Earthquakes and volcanic activity. So if the earth begins to shake with earthquakes or even shake through these eruptions, that shaking can make the sediments move on the surface, and that can initiate your rock falls, your slides, and your flows. Next one, human activities such as construction, right? Building highways through and cutting through the land, creating steep slopes. Sometimes building homes in which the homes can be surrounded by some steep gradients, like cutting through the earth. All right, deforestation is huge too because you're removing the trees and you're removing the root systems which help anchor the soil in place. All right, last few things. We have shear stress versus shear strength. So the shear stress is your downslope force, right? So that downward force, gravitational force, shear stress, is greater than the shear strength, the resisting force, right? That could be your earth materials, and mass movement will likely occur. Right, this relationship. Once again, shear stress is greater than shear strength. That downward force is going to bring the materials downhill, right, in the form of mass movements. All right, next one. I have one more after this, I believe. Angle of repose. We touched upon this at some point last year or this year. Most materials will have an angle of repose. So I think we looked it up for sand. Sand roughly has an angle of repose around 32, 33, 34, 35 degrees. And that's the highest you can pile up sand before it begins to fall over. All right, so the angle of repose is the steepest angle at which material remains stable. Loose, unconsolidated particles. Beyond the angles for the earth material will slide or collapse. All right, if you exceed it. All right, last one, water's role. All right, small amounts of water can increase cohesion. Right, will reduce the stickiness of the earth materials, this loose, unconsolidated sediments or soils. All right, too much water will definitely add the weight, increasing flow downhill, reduces friction between each piece of sediment or each piece of soil grain and cohesion, acts as a lubricant. Right, and this lubricant can make things flow easier. All right, increase pore water pressure. All right, the pore spaces become more saturated and can exert more pressure in there. All right, and that's it. Okay. All right. I will post this up, and you can practice some questions on Nearpod. I'll make the I'll put up some videos. You can watch some videos to help you and answer a few questions. All right, guys, have a great day and thank you.